Dear students, welcome to our class on weather forecasting for agriculture 7. So with this class, we try to complete the different bands which sense from the satellites. Okay, different bands which sense what component of the information, what component the each sensor will measure. That is thermal infrared 1, thermal infrared 2, CTBT, cloud top brightness temperature, CTBT, then RBG composite images are red, blue and green images, microphysics of that. So each one maximum 1.5 minute I would like to share with you. Thermal infrared 1, as far as weather forecasting for agriculture is concerned, different payloads we have. Okay, say for example, you take a satellite is like this. A satellite is like this. Uh, it is this is the satellite and this is the rocket. Okay, so rocket is ignited, it goes up, rocket falls down. Okay, it carries along with it, rocket falls down, and the satellite may be geostationary or polar orbiting, or different satellites are there. In that, different sensors are there. So in the earlier classes, we tried to understand some basics up to the level of agriculture meteorology only. We try to understand. Here in this class, what we try to understand are thermal infrared 1, thermal infrared 2, that is CTBT, cloud top brightness temperature, and with reference to the microphysics of RBG, red, blue and green. So these are the things that we are going to see. First one, the thermal infrared 1. What is thermal infrared 1? Thermal infrared 1 is 10.3 to 11.3 microns, where 10.7 microns has a very good 10.7 microns of that particular wavelength. So it measures the temperature of the object. It measures the temperature perfectly. That's why it is called as a very. It is by definition. We call it as a clear atmospheric window. What we call it as clear atmospheric window. There is a dirty atmospheric window. This is a scientific term. I must use it. You should learn it. So here in the thermal infrared 2, this is 12 microns. That is dirty atmospheric window. Why it is called dirty atmosphere? After 1 minute I will tell. Now see the thermal infrared 1. Okay, that may come as a bit. That's why as a student you should know it. As a senior professor, using that word is of course something is inconvenient even for me as well. Okay, right. Now anyway, it is there in the science. We should learn it. Now, so TIR thermal infrared 1, 10.3 to 11.3 microns, 10.7. What is 10.7 microns? There is a great test about that one. It's called as a clear atmospheric window. That will come. Now, the band between 10.3 and 11.3 microns are called a thermal infrared 1. Around 10.7 microns, in that particular 10.7 micron region, most of the energy radiated from the surface reaches the sensor. So 10.7 microns, at that, from that region, the sensor gets very good. That's why, this is just because the radiance emitted by the surface is less affected. Radiance emitted by the surface is less affected by the atmospheric components. Thus, this band is known as a thermal infrared 1 band, particularly at 10.7 microns is called as clear atmospheric window. Now, the temperature measured is close to the scene temperature, used for monitoring cloud top and surface temperatures, cloud cover and air mass boundaries. This much information we get because the cloud top brightness temperature decreases. the cloud top brightness temperature decreases with height. Thermal infrared images show good contrast. Thermal infrared images show good contrast with reference to what? Visible band. Visible band we discussed in the last class and then the previous class. Class number 5 and 6 we discussed it. Visible band, they are useful during the daytime, they have certain limitations. Even though there are certain limitations, we should learn it, okay? It is a science, we should learn it. It's not a technology. So that's why even now also visible bands are used for comparison purposes. Wonderful. Okay, that's what. Now, so this is what I would like to share with you as far as thermal infrared 1 is concerned. Now let's go to thermal infrared 2. What is thermal infrared 2? 11.5 to 12.5. Especially at 12 microns, so what happens is the band is between 11.5 and 12 microns are called thermal infrared 2. The thermal infrared 2 window region around 12 microns is contaminated by, that's why it is called as dirty window. It is contaminated by what? Low level water vapor. Low level water vapor in the atmosphere, and thus it is called as the dirty window. The earlier one is the clear atmospheric window. This is a dirty window, we call it. However, this is used to identify the lower troposphere moisture. In the lower troposphere, what is moisture? Troposphere, stratosphere, mesosphere, ionosphere, exosphere. We are much interested in the troposphere only because cirrus, cirrocumulus, cirrostratus, altocumulus, altostratus, stratocumulus, stratus, and nimbostratus, clouds with vertical development, cumulus to cumulonimbus. So we are interested now. I tell CTBT. CTBT. What is CTBT here? Okay, cloud top brightness temperature. The CTBT is the temperature. Okay. Usually, we take for all the practical purposes in the payloads clouds as the black bodies. Even though they are not perfect black bodies, we take it because different types of clouds are there. Cirrus, cirrocumulus, cirrostratus, altocumulus, altostratus, stratocumulus, stratus, nimbostratus. So these many clouds are there. Very big systems are there. Convection is there. Shear stress is there. Shear. Lot of shear is there. Just when we take a book and then move it like that, sharing. So to avoid all these complications, so we take the clouds emissivity as one, treating them as black bodies. There is no other way as of now. Okay, some in the future, younger generations, you may find something else. But as of now, we take clouds as the black bodies, where emissivity is one. Of course, even though cloud is not a perfectly black body, for derivatives of the cloud top brightness temperature, cloud is assumed as a black body. The CTBT contour, here what we wanted is, we wanted certain contours of cloud top brightness temperature. Contours. How these contours are helpful? Okay, these contours corresponds to the higher vertical growth and intensity. Higher vertical growth and intensity. What intensity? The more negative value of CTBT. CT, cloud top brightness temperature, more the negative, it corresponds to the higher vertical growth. That's why cumulus will form into cumulonimbus, vertical growth. Okay, and intensity, with what intensity the growth is going on. See, thunderstorms, they develop in local thunderstorms, they just develop in few hours. Even with excellent manpower, okay, we cannot. Sometimes flash floods. Okay, for all these things, CTBT are very, very important. Of course, in a separate class, I cover flash floods later on. Okay, now see the very interesting in the INSAT, Indian satellites. Okay, Indian national satellites. 3D. There are two components. RBG components during the daytime and nighttime. RBG means red, blue, and green components. Red, blue, and green components. Now here during the daytime, okay, in the red beam, the visible reflectance at the 0.64 microns. Daytime 0.64 microns. Okay, red part at the 0.64 microns. Okay, approximates the cloud optical depth. 0.64 microns of the window. Okay. It approximates the cloud optical depth, that is the thickness, and the amount of cloud water and ice. The amount of cloud water and ice. What is this? R part in the Okay, in inside 3D, red part 0.64 microns gives an indication about the cloud optical depth and the amount of cloud water. Typically, this bit will come, please. Typically, water cloud is more reflective than the ice. Okay, and thus they will have a stronger red beam component. Which will have stronger red beam component? A cloud with water has a typically water cloud is more reflective. So that's why it has got more red component. In the green, let us come to the RZB. Red is 0.64. Now, as far as green is concerned, 1.67. For example, in this 3D, okay, right, microns, it comes under the short wave infrared. Solar reflectance gives a quantitative measure for cloud particle size and phase. In which phase it is there? What is the cloud particle size? It will give the typically the smaller water droplets or small ice particles have a high reflectivity. Small size of both water droplets or small ice particles will have higher reflectivity, resulting in a stronger green beam component. Smaller the size, lesser the space. That is the principle involved. Smaller the size of either water molecules or crystals of ice, So more green component you will find it 4. That is short, not VIB or green here. It is a short wave infrared green. Now, so the blue beam corresponds to 10.8. The blue beam corresponds to 10.8. Okay. Infrared, that is the thermal infrared one earlier class I told. Earlier, just 2 to 3 minutes back. Brightens the temperature as a function of what? Surface cloud top. Okay. The cold cloud tops will not have any contributions in this particular band. In this particular cold cloud top, we won't get anything. Now, here it is with reference to the daytime microphysics of the daytime red, blue, green composite images. We get different images of red, green and blue. What, when and what are the characteristics of the cloud? How we get during the daytime? Red, blue, green we discussed. No, during the night time only half minute. During the night time, the red beam gives an indication of optical depth of the cloud like daytime. Optical depth, okay? Cumulus is formed with cumulative optical depth. The green beam gives an indication of fog or cloud. Here there is a problem, of course. When I learned in the year 2007 in the United States Department of Agriculture, Beltsville, Baltimore, remote sensing laboratory, I worked there for 3 months. 2 things are there. Fog and low cloud. It is absolutely difficult to distinguish. It's absolutely difficult. Why? Because the surface temperature, over which either the fog is there or low cloud is there. That's why in the basic course we give low cloud is dash fog answer. 1 mark we'll give it in the final exam or midterm. So low cloud or fog is absolutely difficult. Earlier, nowadays it is possible. Earlier when we were looking at the visible part of the spectrum, it is very difficult because the surface temperature of the earth, because it is already low, surface temperature is almost equal to fog or low cloud temperature. There is no difference between the surface, low cloud or fog. So that is what I would like to share with you. This is with reference to the green beam. Finally, the blue beam gives an indication about the cloud top temperature, CTBT, cloud top temperature, like earlier. So, thanking you for your patient hearing in this class.